Okay, so here is a quick update of what I've done over the past 2 weeks, mainly three. So the first one is the mobile risk protection SDK that is integrated into your Android app or Android client of the gaming app. The second one is to basically leverage a decision engine is highly customizable, leverage AI and machine learning. That is the solution that basically most of the edge protection solution can provide, which is the flexibility and also the custom, the AI library that you can use to build that is a custom or adapted to your user patterns, right? That's most important. And the third one is a quick demonstrations of the WAF and antiddos, how it works on the commercial solution that will be implemented to prevent some of the bots, some of the volumetric DDoS attacks to the game server. So going to demo each of them one by one. So the first one is the Android app, right? So over here, this is the app that is already integrated with some of the commercial mobile protection SDK. But that is not considered a complete solution because, I mean, what you can do is just on the mobile end, right? But eventually what a client or what a gaming operator wants is actually the centralized bot protection, right? So basically over here, the SDK, what it would do is, of course, it will be, just give me a moment, let me just quickly fleck out the features of it, right? So I'm using the SDK from the Tencent Cloud Solution. So basically, it provides you with the SDK that can detect some of the device level risk. For example, I'm using the emulator. I should be able to get blocked. I'm using, for example, some of the automated tool. I should be able to get blocked. Right. So over here, first of all, I'm going to quickly restart it. Hit I agree to the terms and condition. They see that the capture will be popping up. So what I'm going to do right now is I'm going to quickly pass through the capture. I received the ticket and also the random string over here, right? So basically, this is where some of the edge protection solution are going to use, right, to get the risk code and then decide whether I should get blocked, right, in terms of the HTTP send and receive request once it reached the server. Right, so basically over here, I should be able to get blocked. Why? Because I'm using the emulator. I could hit submit, forbidden. Why? It's actually due to this reason. So over here, you see that I'm using the app. It's using AI and machine learning to detect whether there are potential risks. And then over here on the edge device, right? So edge device, so basically it can perform some of the functions lookup to see that, hey, what risk code that I'm gonna fit into, right? For example, I'm having a risk code of 301, which means that I'm using an emulator, and then I will get blocked, right? So that only the clean traffic will be sent to the server. So over here, this is the server supposed to receive the message. However, you don't see nothing, right? So why it's not receiving nothing is because it's all being blocked here. Right, so over here, this is the something similar to what Akamai or Cloudflare provide. That you see that over here, I'm having a site and if you go into the analytics over here, right, so basically it just happened not long ago. Let me just go into the analytics. Right, you see that the right device risk category 3 Wi-Fi, right? So basically it's because that from the SDK that it so over here, right? So the reason you don't see the risk code over here is just in case that it could be tampered very easily on the client side, right? So what you will get is the ticket, a string that is very difficult to interpret. And then with this together, the HTTP request being sent, and then on the edge, the logic of it is on the edge, right? That you're going to use the functions over here. So there's also a chunk of code I written over here that you see. So basically this is the key is to query the API on the back end. But the most important part is basically to interpret the ticket and then get the risk code from the backend server and then make a decision whether I should be blocking this or not. And how should I decide, right, whether I should be blocking this or not? So over here, they have the rule engine, they have the SDK. There you see, if I'm matching this list of the risk code, and I should be able to receive a response status code as a 403, right? So if I'm going to do that again, just to quickly refresh your memory, um, so I'm going to quickly restart and run again. Because over here at the device level, because I'm uh, attempting multiple times already, so I have to pass another levels of capture, which is slider puzzle, and I'm going to receive the tickets. But unfortunately, I will still not be able to send the message, right, because that I'm using the emulator. Right, so basically, this is how the entire solution works: the integrated edge solution and the SDK solution. And the reason I'm not receiving the risk code over here, that you're not able to see that, is because that if you receive the risk code over here, and you attach the risk code alongside with HTTP request being sent from this client, it can be easily tampered, right? Instead, you just send the tickets over alongside with HTTP request. From the attacker's perspective, I don't know whether the ticket is considered good or bad, right? And then on the edge, and then make a API call to the backend server, and then retrieve the risk code over here. Right? If I match any of them, I'm going to send the response code, which is a 403. Right. So basically, this is just one way of doing that. And in order to visualize it, right? So um, over here, that you will be able to see that for example, the top UA, I embed basically the code into the UA, right? So that from here, you will be able to see that the 301 and the 501 risk code over here. And why they will be appearing at the UA is because that over here in the edge functions over here, uh, that I basically had this the risk code and had that embedded into the UA streams over here, so that on the UI that you'll be able to see the risk code as part of the user agent, right? So basically that is the entire solutions. Oh. So basically, this just wrapping up the first solutions. It's pretty complicated, a pretty complicated logic, but highly secure. Of course, the local device will never receive a risk code. It's never get tampered. And the risk code can only be interpreted on the server end and make a decision whether I should be blocking it or not. Oh. So basically, this is the first solution. And the second solution I'm going to demonstrate is I understand that in most of the cases, that fixed solutions like what Cloudflare, Akamai, or Tencent Edge One does is not sufficient, right? Because these are all the fixed rules. Barely the any provider give you the capability of, for example, building up your own AI libraries, leverage the data of your own, right? So, but most of the time, the user patterns are different from client to client, game operator to game operator. So that in order to basically best fit the model into your use case, you must use some of the sort of open source AI library tools in order to build that. So over here, for the simplicity of demonstration, I'm using a UI-based AI training library, and we're able to build some of the models and also the decision flows based on the data I submitted. So basically, the data is over here. I have to highlight that each user has to basically upload his own basically set of the user data or historical data. So the model being trained will be highly accustomed to your or to this particular game operator's user pattern. So it'll be more accurate to determine whether it's a fraudster or not. So over here, let me just quickly show you that what I've done. I'm going to quickly run through some of the automated training. So you know that it is a framework called Auto ML, right? So I'm leveraging on that. So on the UI tool, I just need to determine, for example, 70% using the training set, 30% using the validation set from this data set, and this CPU and memory resources are used to train. And of course, that you have determined that what feature is required, right? The label column, the weight column. If I were to basically determine one of them is weight, I mean, if you're dealing with the imbalanced data set, probably I need to turn on this. And then I'm going to select what uh, um, algorithm I'm going to use, right? For example, scorecard is basically to determine that how good, how bad this particular user is, right? Logistic regression, that is one that they use to train, because it just simply tell you the binary result of it, right? Yes or no, good or bad, easiest, right? So in some cases, probably you can use the clustering for the classifications, right? Some of unsupervised learning algorithm in order to label the data, etc. So over here, training it, I'm just using the sort of intelligent parameter searching features over here because, I mean, now there's a lot of open source libraries that allow you to basically train based on certain objectives, right? So for example, highest or most optimal KS value or most optimal AUC values. Or so after model being trained, I will be able to view it. So extremely high AUC, right? Cause I mean the number of data that you need to train is pretty limited, so that I'm able to achieve the highest ROC AUC value, and also pretty high, very high KS values over here, right? So after the model being trained, it just sort of a mock lab, right? So after model being trained, the next step usually is to apply the model into a decision flow, right? So a lot of like open source decision flow tools as well. So over here, I'm going to quickly show you that uh, how how it works theoretically. Just give me a moment. Uh, it's pretty slow. So if you go into, for example, the decision engine, I'm going to quickly show you the canvas over here. So, so for example, I'm going to detect fraudsters, and just like in and out, right? So fraud detections over here. So input and output value is pretty simple. I run a test. For example, IP risk score, AT device risk score, and also account age dates, right? So the account only being there for like 4 days. I run a test, and then it's still running. Let me just quickly refresh it. Okay, it's failed anyway. Let's see the reason. Okay, there must be some reason, but just quickly show you that the successful one it is, right? Because I mean the platform I'm using to build is pretty I mean with limited resources. Sometimes it works, sometimes it no, but usually it will just tell you that for example the final score, whether it's high or low, the probability high or low, right? So basically just how practically it can be applied into the scenario, right? And apart from that, some of the blacklist on the whitelist use cases, right? So for example, on the decision flow, I want to query some of the external data, right? So over here, I've built a server that is basically simulating a blacklist, right? So from here, I will see that whether this particular new registered user is under, for example, the session list, right? So trying to like top up and do some money laundry. And then, for example, if it's Mike, right? I'm going to run the test. It's not sanctioned, right? So from here, there you see, oh wait, all right, so there's a match result. Okay, game server, it's already reset. All right, so over here they see that there's a match result. Okay, so over here is not sanctioned, right? So and then, for example, it's Jack. Start testing. Sanction, right? So basically, this is just showing you that how I can query external database as part of the flows that basically you can use that to block those like fraudsters or potential attackers, right? So basically, this is how we're going to use an external open source decision flow and AI library in order to further enhance your cybersecurity platform, right? And last but not least, is how a typical, for example, edge protection solution looks like. It's sort of a commercial one, but it's pretty standard across all different vendors like Akamai, Cloudflare, right? So basically, over here, the first one is the web security, right? So over here, look at the right hand side, right? So usually go through these flows, right? So rate limiting, some of the custom rules, right? And bot management, and also some of the management rules, right? So over here, I'm going to quickly simulate, for example, the cross-site scripting attack, right? And so basically, you'll be matching one of them, right? And then later, you're going to appear on the analytics portal, right? So over here, to quickly show you. So over here, I'm going to see a sample logs, right? So some of the previous attack that were launched, right? So basically going to show you that user agent is, since I'm using um, this as a testing method, a user agent, I just put it as a test cross-site scripting, right? So that they will be able to see that some of the like, script labels being embedded over here, right? So basically, just for testing purpose, showing you that from the edge, that you will be able to visualize all the incoming requests, and that you will be able to block those like malicious requests. And the other one that is very important is the DDoS mitigation, right? So it could be layer 7, it could be layer 4, right? Since I mean I have the cost constraint, so that I'm not turning it fully on. But anyway, I mean you're going to protect yourself against this layer 7, layer 4 DDoS attack. And yeah, so basically this is pretty much of a demonstration how a client-side SDK works, how a decision engine works, and also how the sort of a commercial WAF and anti-DDoS solutions works. Thank you.